The work of Nobel Prize has transformed our understanding of the world. While approaching the Nobel Prize winners in chemistry, we not only learn their achievements, but also the spirit of honesty, tenacity, innovation, and forging ahead.
Hello everyone, welcome to today's class, the Nobel Prize winner in chemistry. 同学们，你们好，欢迎走进今天的课堂，走进化学诺贝尔奖。今天会给大家介绍的科学家是威拉德·弗兰克·利比。Today I will introduce you the prize winner of Nobel Prize is Willard Frank Libby for Archaeological. Hi guys, do you like travel historic places of interest? Are you interested in archaeology? And do you know how to determine the age of fossils and relics? Let me introduce you a Nobel Prize winner in chemistry today to see how he did it. Willard Frank Libby won the Nobel Prize in chemistry in 1960. He worked for the University of California in the United States. He won the Nobel Prize because his method to use carbon-14 for age determination of archaeology, geology, geophysics, and other branches of science. He is a physical chemist and a specialist in radiochemistry and particularly hot atom chemistry. He is good at tracer techniques and isotope trace work. He became well known at the University of Chicago for his work on natural carbon-14 as the radiocarbon. Carbon-14 is used in dating archaeology artifacts and is used in hydrology and geophysics. How to measure the age of archaeology artifacts? First of all, what is carbon-14? Carbon is a fundamental component in all living material. In nature, there are three isotopes, carbon-13, carbon-12, and carbon-14. Carbon-14 is radioactive. It forms in the atmosphere when acted upon by cosmic radiation and then deteriorates. When an organism dies and the supply of carbon from the atmosphere stops, the content of carbon-14 declines through the radioactive decay at a fixed rate. In 1949, Willard Libby developed a method for applying this to determine the age of fossils and archaeological relics. It has been known since 1939 that a cosmic ray creates showers of neurons on striking atoms in the atmosphere. And the atmosphere contains about 78% of nitrogen, which absorbs neurons to decay into radioactive isotope carbon-14. Libby concluded that the trace of carbon-14 should always exist in atmosphere carbon dioxide. Also because carbon dioxide is continuously absorbed by plants and becomes part of their tissues, plants should attain trace of carbon-14. Since animals consume plants, animals should likewise contain trace of carbon-14. After a plant or other organism dies, no additional carbon-14 should be incorporated into its tissues, while that which is already present should decay at a constant rate. The half-life of carbon-14 was determined by its co-discoverer chemist Martin D. Carman to be 5,730 years, which compared to the age of the Earth is a short time, but one long enough for the production and decay of carbon-14 to reach equilibrium. In this Nobel presentation speech, Swedish chemist R. Willard summarized Libby's methods. He said, because the activity of carbon atoms decreases at a known rate, it should be possible to determine the time passed since death by measuring the remaining activity. If it occurred during the period between approximately 500 and 30,000 years ago, Libby verifies the accuracy of his method by applying it to samples of fir redwood trees whose ages had already been found by counting their annual rings. They also measured the age of artifacts, such as wood from the funeral boat of Pharaoh Sesostris, whose age were already known. By measuring the radioactivity of plant and animal material obtained globally from the North Pole to the South Pole, he showed that carbon-14 produced by cosmic ray bombardment varied little with latitude. This table showing here is the measurement results of radioactivity intensity of carbon-14 at different latitudes. On March 4, 1947, Libby and his students obtained the first age determination using the carbon-14 dating technique. He also dated linear wrapping from the Dead Sea Scrolls, bread from plates buried in eruption of vessels AD 79 years, and charcoal from a Stonehenge campsite and coal cobs from a New Mexico cave. He showed that the last North American ice age ended about 10,000 years ago, not 25,000 years ago, as previously believed by geologists. It's in notation Libby for the Nobel Prize. One scientist stated that seldom has a single discovery in chemistry had such an impact on the thinking in so many fields. Seldom have the single discovery generated such wide public interest. After showing the essential uniformity of carbon-14 in living material, Libby looked for the answer to the second question by measuring the radiocarbon level in organic samples dated historically. Materials as old as 5,000 years ago from sources such as Egyptian tombs. In 1950, Libby used this method to determine the construction age of pyramids. It's incredible coincidence with historic records. Since the carbon-14 dating method is based on the change of the nucleus and it's not affect the physical and chemical conditions of the surrounding environments. As we can see from the picture here, the half-life of carbon-14, 5,730 years ago, is suitable for the determination of samples from thousands of tens of thousands of years ago. In addition, some carbon-containing materials, such as wood, grass, shells, and other animal and plant remains, are everywhere in ancient sites, and it's convenient to obtain specimens. Therefore, the carbon-14's dating method is widely used in the study of prehistoric archaeology and late Quaternary geology. However, the carbon-14 dating method can only be used for organisms that have died for tens of thousands of years. For some organisms that have died for millions or even hundreds of millions of years, the carbon-14 content in the remains of this organism has been too low to be measured due to too many half-lives. Therefore, this method cannot be used to measure the age of these organisms. With the help of American Archaeological Association and American Geological Association, Libby and his colleagues measured a large number of cultural relics and prehistoric number of relics of known ages to verify whether the carbon-14 dating method was actually available. Here is the graph for the carbon-14 dating of known historic relics. After this class, I hope you not only know about Professor Libby, but also have some ideas about how to determine the age of fossils and relics by carbon-14. This is today's Nobel Prize winner. Thanks for watching.
同学们，咱们在物理化学这门课中，是不是学过半衰期及其相关计算？对的，埋藏地下深层的沉积地层的样品，只要按碳十四的放射性衰变公式进行计算，便可推出待测物品的存在年代。利比是著名的物理化学家、放射化学专家、热原子化学、示踪技术、同位素示踪技术专家。1960年，鉴于利比发现碳十四年代测定法，为人类创造出独特的计时工具——考古学时钟，他被授予诺贝尔化学奖。由于碳十四年代测定法依据的是原子核的变化，不受周围环境的物理化学条件影响，所以碳十四的半衰期5730年正适用于对几千年到几万年前的标本进行测定。另外，一些含碳的物质，如木、草、贝壳等动植物遗骸，在古代遗址中普遍存在，获取标本很方便。因此，碳十四年代测定法被广泛应用于史前考古学和第4纪晚期地质学的研究。好了，本次课到此结束，谢谢大家，再见。